So in this video, we're going to carry on and store the login token and details once we've logged into the Facetto Word server. So the last video we logged in using this login web call here. And then once we've got the data here, this user data is what we need to store. So right now we simply just set up some view model information and don't do anything with the token. So we're at the point now where we need to store information. So by default in a Windows application like this, we've got multiple ways we can store data. We could write a text file, we could write a binary file, we could do JSON, XML, database. We can do many different ways. What I'm going to do is make a database using Entity Framework so that we can write basic POCO classes, just plain old class objects, normal C# classes to store the information in. And use a nice little interface and service between that, so we can simply, save and pull details without worrying about the database backend. So we've already done the database in the Facetto Word server, and for that we used SQL Server. The issue with doing that on a desktop computer, say this goes to your machine or your friends' machines or the general public, people running Windows 10 won't have SQL Server installed. So that's not really an option for SQL Server. The beauty of Entity Framework is you don't need any specific database. With one line of code, we can change what database backend we use. So I'm going to pick SQLite, or SQLite, I believe it's called. And that's a file it'll basically create a file in this folder. So once we've built and run this application, and you get this output, and this is what you install, we'll literally just end up having a database file here, Facetto Word.db. So that's what we're going to end up with when we build an SQLite database. So we're going to get to it. The first thing is we want this Facetto Word core is shared between all the Facetto Word projects. So in here, the first thing we really want is an interface defining basically a service. So we're going to go and make, I think it could go in IOC interfaces, and we'll add a class. Well, it's going to be an interface, but we'll call it, in fact, click interface, then we'll get an interface. We'll do Client Datastore. Could do any other word really. Get rid of the namespace. Stores and retrieves information about the client application, such as login, credentials, messages, settings, and so on. And in this interface, we will need some properties. We don't do public in an interface. We need one which will be if we have credentials, and the reason for that is we'll use that to, in fact, that will be a get only. Determines if the current user has logged in credentials. So we'll use that on application startup to define whether we should go to the login page or not. If they've got credentials, we go to the main page, which right now is the chat page. Then we'll have a task, just so that because this is an interface anyone can implement, we should really try and make everything asynchronous as much as possible. So we'll have ensure Datastore async, which is for ensuring the database exists. This is kind of the setup. So again, namings, we can change the name as and when. For now, I think that's an okay name. Make sure the client Datastore is correctly set up. Well, in fact, no, setup's better that way. I need to keep trying to remember to use these returns. Returns a task that will finish once setup is complete. One more, we'll have a task again. And for now, we didn't need these login credentials. So we'll need login credentials. We've got API model, which is for the web calls. We also now need a data model, which is for the backend store. So we have a folder for data models already, which is kind of not really used correctly, but I'll chuck it in there for now. We'll clean that up after. So we'll call this login credentials data model. And we'll fill this in with what we need for the model, which is basically the same as the login model. So we'll have a public string, and because it's a database model, we'll always have an ID, the unique ID for this data model. And this is the unique ID. This is for anything with a data model will always have an ID, so that every item in the database, every row in the database tables is trackable and manageable. So it's just something you need for a database object. Then we'll have all the same info as the API model, really. So we'll have the first name, last name, username, email, and we'll also have the token as well. Chuck these in, and just comment them. The user's username, user's first name, user's last name, user's email, and the user's login token. So that's now a data model ready for use. The data model for the login credentials of a client. And we'll take that, and as part of the interface, we want to return that, and we'll call it get. Get login credentials. Oh, it's got some new IntelliSense that suggests a name. That's cool. I think that's a new feature in Visual Studio 15.3, maybe. I haven't seen that before. So that will simply get any credentials. Get the stored login credentials for this client. And then we'll need the reverse. I keep forgetting the returns. Returns the login credentials if they exist, or null if none exist. Then we'll have a task again, and we'll have save login credentials. And that will need login credentials passing in. Stores the given login credentials to the backing data store. And then that will be returns a task that will finish once the save is complete. Yeah, I think that's it. So there's our interface. We now want to implement this. Then what we can do is inject this into our DNA framework service provider, which is our IOC, which right now we've got like a partly an inject and partly the new DNA framework dependency injection. So we're just mixing them together for now, and then we'll clean up afterwards. But basically we'll inject a new service on startup that will implement this interface. And then we can make use of that to, once we've logged in, call, save login credentials. And once we open the app, call get login credentials to see if we have them or not. So that's what we're going to do with that. So what we want to do here now is make a new project. Class library.net standard is fine. Falsetto.word.relational for relational database. And that should add project. I think that's all we need for now. This will need a dependency for the core, because it's going to reference core. And in here, we'll call this, we need to implement that interface. So we'll have a Client Datastore. And rename the class, that's correct. So this class will be responsible for, let's just get the interface here, and pretty much can copy the interface comment, that's fine. So as long as we and so on in, and this one will use an SQLite database. So this will want to implement that Client Datastore. And so we have public properties and then interface implementation. and I like to just copy the interface comments. You don't technically have to when you export the comments because they'll get pulled in from the interface. And I know this is a bit of duplication of comments, but I can't stand seeing, methods without any comments on. So even though they technically pull through, I like to copy them. And I know it's a bit of a pain, like I say, because then if you edit one, you've got two to edit, but just my preference, I like to do that. Plus then if the specific implementation decides to do something slightly different, or you want to add some more specific information like we did here, then you've got that option. So that's kind of how I look at that. And the point of all these comments is obviously for one, if you export this to a NuGet package, you'll have comments when you type in any of these codes. Two, it's really good practice. And three, it's, again, your own, well, there's even four reasons. Three is your own use that you can read something. And four is if you ever want to export an API documentation that somebody can, if they're going to extend on this, or say you're making an API, people can read an API documentation, you can generate all this automatically in a nice MSDN style documentation. So that's that anyway. So the has credentials, we'll simply call get there's a slight problem. We've got get login credentials as a task. So this cannot be this cannot do that because we need to await that. So I will make, in fact, that's also wrong anyway. I've named them wrong. Let me just quickly check that. This is get login credentials async, and this is save credentials async because it's asynchronous. What we will do here is we'll make a new one specific to this method called get login credentials. This will be protected methods. So this isn't part of the interface, but all this is going to be a non asynchronous function so that we can call it from a property. So that'll do exactly the same thing, it just won't return a task because we won't need to do a task anyway. So we'll come to that in a second. Then, well, in fact, before we can implement this interface in any way, we need to actually make the entity framework. So let's just jump onto that for now. So we have the relational. What if I click there? Oh, that's actually what I wanted to do. Go to there. So in here, we need to have the Microsoft.Entity Framework core.SQLite, and you want to install this package here. Install that. Okay. Accept. And there is, I believe there's a bug in this. I tried this earlier. Even though we have a package here, a C# .NET Standard library, if we were to reference this, which we will in this Facetto Word application now, we'll add a reference to this project because this is one we're going to make use of. If we were to run this, which we'll do first so you can see the issue, it's going to complain when we finally get it up and running that it can't find a SQLite's DLL in this application, even though it's referencing this. So I'm pretty sure that's a bug, which I'll show you how to fix after. And then we should really report it to the GitHub repo. But anyway, we'll come back to that. So in the relational project, we'll make another class, and this now needs to be the actual entity framework database of the other DB context. So we'll call this the Client Datastore DB context. And then in this wants to implement its own DB context. And this will be the database context for the Client Datastore using Entity Framework and SQLite. Well, in fact, that's a bit of a pointless piece of information there. So we've got the constructor, that's fine. Then obviously, same as the website project, this is effectively, you can think of it as your database. I know it's the poker representation of a database, but that's what you can look at it as. So this is a region for DB sets. DB sets you can think of as tables. So if we do a public DB set and we now pass in the login credentials data model, because that's what we want to store. We'll call this login credentials. This is now this will be a table then called login credentials in the database. And this will have as many rows as we want to add of this item. There'll only ever be one right now, but that's fine. So the client login credentials. Then the constructor for DB context needs to be different. So you need to pass in DB context options of the type of this Client Datastore DB options so that it can be configured. And just pass that down into the base. We don't do anything specific with it, we just need to set up the constructor correctly. And then we'll have a region for model creating. We'll just override the model creating. Configures the database structure. Ooh, can't spell today. Structure and relationships. So we can do inside classes like this that we then make a DB set. We can add specific properties like, say, the key here. And if you control dot, well, in fact, you can't add it there because it's not referenced. This doesn't have a reference to the entity framework stuff. In fact, I think it should still be there. But anyway, the point is you can add specific ones into here relating to entity framework things like, I think it's is. I can't think of any off the top of my head, to be honest, but I think it's like is required or just required, and then max length and things like that. And you can tag your table. These are table columns, basically. They'll get created. You can tag these with set types of the unique IDs in the database, if you've got a max length, if you want a specific name, things like that. You can also do it in this on model creating. And if you do it in here, it's called Fluent API, and you can configure it this way. If you do it in the model there, don't know what the name's called, but basically this, you'd be tagging it with attributes. I don't like to mix the two, so I don't like to say put a unique key on here and say a max length of a username for 30 characters, but then inside here start configuring that the email has to be a certain length or a certain size. I either like to do it all in here or all in here. And there's reasons I do it in Fluent API. One is because the attributes that you can tag on these, you can't do everything with the attributes. There's limits to what you can do. You can't fully configure a database table purely from the attribute tag. So straight away, it can't do everything we need. So we'd have to end up having a split partial configuration here, partial configuration here, which straight away I don't like. What is another reason? Another reason, I guess, is like I say, if this is in core, this is completely unaware of what your data structure is, your relational data structure. It's not even aware whether it's entity framework. It doesn't really care. So you can't go presuming and tagging this class that's in the core, that's got nothing to do with the database, with database specific tags, because then it's murking the separation, the clean separation. So with those 2 points alone, you don't want to configure the database tables, if you will, these data models in the class itself, even though to be more obvious when you were reading the class because of the things I've just mentioned. So instead you'd do it here, and to do it you just simply type model builder dot entity, and then you pass in the type of the DB set, so in this case to be this, and you do the entity, and now you can configure it. So like has key, it's like setting up a unique key, primary key. So for that you'd say has key, and then you just have an entry and you'd pass in ID column. So this is now an instance of the login credentials data model, and you're telling it which property has got the key. So there you go, you configured set primary key on login credentials, or rather configure login credentials, and then that would be like a little header because you do multiple things to configure it. And then you would have set ID as primary key, and then you could do dot and then do some more. Has name, has annotation, things like that. So you can configure a bunch of stuff as you want it to, and you can see you've got way more options. Has many, has one, owns property, so you can get a specific property, say like first name, and then you can and now you can say set the column name, set if it's got a default value, the field, the length. So things like that has max length. So now we'd say we want the first name to have a max length of, say, 50. And these are things that I say are important. Never really leave, just say, these fields as being envar max in like an SQL database, if you will, because that means somebody could make a username that's 2 GB long or something stupid like that. So we should get around to setting these limits up. For now, though, I'm just going to leave it out because it's more time and not the point of this initial subject. So I'll just put a to-do for setup limits. Also, you don't technically need this has key because by default, Entity Framework will look for any property on a model that's a DB set. And if it's already called ID, it presumes that's an ID column. So it actually makes this automatically. But I like to do it so it's explicit. I like to see that it's definitely done. I don't like to leave it up to default behavior, if you will. So this DB set now will create, if we make use of this DB set, it will create the database for us. It will create it where we want and how we want. And then we can access login credentials. We can add properties to it and then save to the database, and we can retrieve from it. So that's all that's really needed to, get the whole database working. So if we now jump back to our data store, which is this is the helper interface that our application will be aware of and make use of to do what it needs to do. We can now make use of that database context. So we're going to make use of that context by dependency injection of the context. So this is going to be created by our DNA framework service provider, which is just underlying. It's just the built-in .NET Core dependency service provider. And we can then just say framework.services.get and get a service that's got this. So it's just normal dependency injection stuff that we've done already. So we'll inject this into the dependency service. And then when the application wants to get hold of this data store, it will be created scoped because underlying it's going to be using a database. And just like the website, you want it to be scoped. You want to simply create the database context, do what you need, and close out as soon as possible. Think of it like opening a database connection. You want to connect to the database, query it for some users, say, and then close. You don't want to leave that connection to your database permanently open, because then when you get, say, 1 million users on your website, you'd have 1 million open connections on your database sort of thing. So it's not that plain and simple, but the point is you want this to be scoped. So it will get created, used, and disposed rapidly. And the way that dependency injection works then is you'd inject this. When you create it, you request for it. So now in a constructor, we can use constructor injection and ask for a DB context. So when this class gets created by the dependency service, it's going to need to be given a database context, which will also be in the service provider. So I'll show you how that all mingles together in a minute. This will be default constructor, the database to use, and then we will have, we need protected members, and we'll have protected client Datastore DB context, DB context, the database context of client store. So that's what we want. So the DB context now, set local member mdb context equals DB context. So when it's created, we've now got hold of this database context. So now we're good to go to start using that database context. We have now ensure, just like we did with, again, the ASP.NET website, to ensure the database, just chuck an async there. We want to await the mdb context.ensure, database.ensure created async. And that will simply make sure the database exists. And that's all we need to do. So that's the same thing we're doing in the ASP.NET Core website. We're making sure the database exists first. Next, we have get login credentials. So this is just as easy. For one, we've just got get login credentials here. And we're not using async because we want to make use of the public property, which I could change to a a method, to be honest. So in fact, let's do that. Let's just make this a method so it's cleaner. And then we don't need the double stuff. So this would just be return, and this would be async. In fact, it'd just be a task of boolean has credentials, and it return that isn't equal to null. In fact, that would need to await that now, and that would be async. Delete the duplicate method. Whoops, I think I pressed F5 to build. So we have, no, we don't want to run. We have a new way of doing this, which is a task has credentials. So if we just go into the interface and update it the same. So instead of it being a property, it's now a task the same. What's that complaining about? Expected that. So has credentials is now a method. We'll move that into the methods. And there we go. So now it's now a method, so we can use a task and we can await it, because you can't await things in a property. So that'll simply say, do we have any login credentials? If we have, we're logged in. So the now get login credentials call will be as simple as, again, mdb context dot login credentials dot first or default. And all that's doing is just like you do on a list. This is getting whether we have, an item in here, basically the first item in the database table, login credentials. You can see this is going to complain because this is an asynchronous task, just in case we need to be asynchronous. As I mentioned, you want to keep it asynchronous. So if it's not a task, if you nothing to await, then you can just do task.fromResult and return the value, and it'll create a task that simply returns instantly. So there's, how we return that. So get the first column in the login credentials table, or null if none exist. That's what the first or default does. So first, if you did just first, this would then crash and throw an exception if there was nothing. First or default will simply return null if there's nothing, and that's what we expect to do here. And that's all there is to getting the information from the database. And it'll even effectively convert itself to the login credentials data model, because that's what Entity Framework's doing for you. It's doing all that magic for you. So it couldn't be any easier. It looks super, super simple. So then the last stage is to save the login credentials. So just the same, we'll do a tiny bit more work here. So one thing you've got to bear in mind is if we're saving the credentials, just to be safe, right now there's only one credential. We could just simply say, get the first credential, update it, and then save. Or we could just remove the first credential, add the new one back and save. But just in case anything goes wrong with the database, or it's manually edited, or for whatever reason, I want to clear all entries in the database table. So there's no login credentials when we're saving. We delete the first one, add the new one. And we can do that. There's multiple ways. What you've got to bear in mind is this would be technically a slower way. So all we're going to do is say for the login credentials, remove the range, and literally remove the login credentials. So we're telling the login credentials to remove a range of credentials, and we're going to pass in whatever range we have. So we're just going to remove all the entries. Now this will probably compute and compile down to an SQL statement that would execute, say, much larger statement. We could go dbcontext.database.execute. What's it called? There's something in here for. Where is it? Oh no, it's a helper. I think it's in an extension method somewhere. You can run SQL directly. I don't know what the name is. It's in an extension method somewhere. But it's an easy Google. But we could instead execute directly on the database a truncate table, and then name of login credentials, and sort of truncate the table. That would be the most efficient way to clear all entries. But because, as I mentioned, this should only ever have one, and this is only in a rare case that something's gone strangely wrong, I don't really care if this is slightly inefficient, and say there was 5 entries, it's going to run 5 statements or something. I don't really care because it should never happen. So I'm picking the option that's cleaner code for now, that's nice and simple, because this shouldn't actually ever delete more than 1. So that's why I'm picking that. But yes, there is more efficient ways to drop a whole table of, a whole row of table. So that's clearing off any previous credentials. Then we want to add the new one. So that would be context. And you can almost think of this like just accessing a list. You hardly realize you're accessing and talking to a database because you're basically working with a DB set, which acts almost just like a list. So you can just do login credentials.add, as if we're adding this new login credentials item to the list of items. And now save changes is what actually commits it to the database. So this is what then ultimately commits the, all your work to the database and runs the SQL query. So we'll await it and we'll add an async there. And that will save credentials to the database. So that is now, again, fully done. So the whole database side is done. Next step is we want to add this relational data as a service to our Facetto Word application. So we'd want to do that inside app.xaml.cs. And then here's the DNA framework we're using. And do we not have a spell checker file on this yet? Let's add one. Add spell checker DNA. Save. So here we'd ultimately want, this is where you're injecting your services of what to use. So here we want to say use Client Datastore, and that's it. That's all we want to be able to, or rather we should have to and want to have to do. So to do that, as we've done with, again, the ASP.NET Core website, if you're following that series of videos, we want to make an extension method on here. So we can make this an extension method. And for that, we'll call it framework construction extension methods. Nice long name. Or in fact, we could just call it extensions. Be a bit smaller. And yep, rename the class. So, extension methods for the framework construction. And then we'll see that in a minute. I'll come back to that. Framework construction. There we go, using DNA. So, extension methods for the framework construction. All extension methods go in a static class. This is static. Constructor we don't have. And we will call this one public static framework construction is what we want to return, so we can chain them. That's how they all work. And we'll call it use Client Datastore. This turns it into the extension method. So framework construction is what we want passed in. Oh, and that is now an extension method. There's obviously return framework for chaining. And that should stop complaining now. So there we go. That's a boilerplate extension method, use Client Datastore. So we go back to here, control dot, it should find it, use relational. So now as part of our setup, when the application starts, it will then call use Client Datastore, which will come into here, and now we can inject our SQLite EF Datastore. And to do that, we use, again, this is all standard for injecting a service into our application. So construction.services, and we can add, directly add a service, but for DB context and for them to be scoped and things, there's the helper method, which you've seen again in the web project. Add DB context, control dot, and then there we go using dependency injection. So we can add a DB context of Client Datastore DB context. And the reason for that extension method helper is, for one, it adds the database context as a service so it can be found. But it also then expects us to pass in here an option to configure the database. So we can configure the database at this level. So we do options, and now we can configure, and this is where we'll set up the connection string. And then that's also adds it so it can be scoped, so it gets created. So this is just like adding a service, but specific for DB context, so they're added nicely. So we're going to do, first we need to tell it what database to use. So we're going to use the SQLite. I think that's it, control dot, and there we go. So that's why, because we added that NuGet package for Microsoft Entity Framework core.SQLite at the start. That's why we've done that. You could add a package to SQL Server instead and use SQL Server if you wanted. And the only thing you'd have to change in your whole application is this one line, and then everything would still work, but then it would get stored in an SQL database. So that's the power of Entity Framework. With one line here, you can change it from using SQLite to MySQL, SQL Server. There's a whole bunch of different databases you can use, but your code, your underlying database context, all of your calls that actually do the work, like here, all this doesn't change at all. Not one line of code changes. And to change the whole backend database for the application as one line here. So that's the beauty of Entity Framework. So for this, as I mentioned, we're going to use SQLite, and the reason for that is this is a Windows desktop application. So it's going to run on client machines, normal Windows machines, and we don't want them to have to install a database server. We want it to be a file-based database, and that's what SQLite is. So to use SQLite, it's asking for a connection string. So let's just use the configuration option that we already have set up in our dependency injection that we already make use of. And we'll also make use of the helper method get connection string, which is specific for databases. And this is then going to be Client Datastore connection, say. And all that's going to do, there we go, is look in the configuration which we set up in the DNA framework, which it will look specifically for a file called appsettings.json. And then the get connection string as part of the configuration helper method simply looks in here for a specific heading called connection strings. That's all it's doing, as the helper method is looking for that. Get this right in a minute. There we go. And then in here now it's going to look for this name that we passed in. So that's all it's doing. And this file here is the one that's super secret, that never gets shared when you publish a website. This is where all your secret information is, and it's protected and guarded, if you will, so you never see this file. So in here now is finally the database connection string. So for an SQLite database, it's data space store equals, and then simply the file name. So this is where we'll do Facetto word.db. And that'll now be the database that will get created, that name. So that'll be found via configuration. It will then tell it to use SQLite, and it will use that file name, and this is a relative path because we haven't provided a, you can provide a specific thing like d/ Facetto word. So it's an absolute path. If you leave it relative, it'll be the same location as the executable itself, which is where I'm going to store it for now. We could move that, but for now I'll leave it there. So that's injected. That's now available. And we can make use of that in our application Facetto Word, but we don't want our Facetto Word application to really be accessing the DB context and then doing the calls. That's why we made this helper class here, the Client Datastore, so that your Word application doesn't have to be worried about doing database specific stuff. So this is kind of the bridge between them, this Client Datastore, and that's the reason we did it. So we need any part of our application to also be able to access this interface, this Client Datastore. So to do that, we'll inject add Client Datastore for easy access use of the backing data store. Make it scoped so we can inject the scoped DB context. So as I mentioned, this is a scoped thing that gets created and deleted as soon as possible. So we're going to add our interface in the same fashion. So every time we request it, we get a new one if it's in a set scope. So same as always, just use an add, but this time we'll use add scoped. And you could pass in the object directly, but the thing is we have an interface that it's a type of, but the implementation is a specific class. So we need to pass in the type to the generic helper, saying it's this type that we want to add, but the implementation, we'll need to provide that back, but we need the provider because it's scoped. So we'll have provider, and this is expected now to return new client data store. And this is where our constructor needs the DB context, as we mentioned. And because we're scoped, we get access to the provider of that scope, which is the dependency injection part. So it's this construction.services, the service provider, if you will. So now you can just do provider.get service and just get the client data store DB context. So effectively, you use the scoped provider to get the scoped database context and pass it into our client data store. So that's just injecting our client data store. So when we now try and access it, it will be found and created, and this line will run and effectively create our client data store, and then itself also inject in the constructor the database context it's after, which is available and gets service because we added it up here. So that's this is all dependency injection stuff. The more we do it, the more you'll be familiar with it and okay with it, if you will. So that's that. So I think we're finally ready to actually make use of this. So in here, it will now call client data store. And then we need to actually ensure the database. So we'll set up the framework. This is also the old school one that we're leaving in for now. So in theory, I think what we should do is allow this to get created and all finished down here. So that's kind of your setup done. And then here, I would ensure the client data store. And that's where now we could do await, and we need to get. So one thing you could do is do framework, which is the DNA thing. Up here, using where's framework? Framework dot provider dot get service, and I think I added a helper to DNA framework. Let me just see if we need to update the NuGet package. Yeah, 3 updates. Let me just update all of these. So I added a helper thing. So in the get service, you don't have to do get service and then pass in a type. Let's also update these if they need updating. Yep. Update. And finally, I don't think we have any NuGet packages in this one. So that's all up to date. Right, that's good. So we can do framework.services. Oh, sorry, I added a helper here, service. So you don't even need to go framework.provider.getService and then do type of, and then, or rather, it's already a type. iClient. In fact, no, I think you still need to do type of. You can't just do that. So then you'd have to do type of, and then iClient data store, and then you'd have to cast it to an iClient data store. So originally you'd have had to have done that to get what you needed. Instead of having to do all that, I added this little helper function service, which is simply like dependency injection ioc.get service. So I just got rid of the get to keep it short as well. So you can simply do framework.service and then pass in iClient data store, and that would get the client data store implementation. It would spin up this, so we'd hit this. So we could actually do that, or go into the constructor here and see that being spun up when we hit this. So let's start with that, which I think this should now build and run at least. And you can see it sort of coming together. So if we can put a breakpoint there. So we hit here. Let me just put a breakpoint in here so you can see this running. So we get to that line, we step over, we get into here. We add the database context with the SQLite, we add this scoped service here, and we return. We then get to this data store, so which we're now going to do framework.getService. You can see this hits now the scoped creation of the data store, which then in turn hits this scoped creation of the SQL server, because it's this line now being run. And then once we get that, we go into the constructor of the database context. So that's been spun up now, as we expected. And then once we're spun up, we then get into the constructor, and then we'll bubble back, and we now have an instance of that class. So now we're ready to use it. And this is where we can now access the login credentials and do what we like with it. So we have this way of now accessing the client data store. So to make it even easier than doing framework.service, we will cut that out a second, and we'll go to the IOC static class. So again, we're just trying to keep the name simple, and just like we've done here with all these helpers to IOC.get, until we fully replace IOC with our specific one, we'll just mingle them together for now. So this wants to get a client data store, and it'll be client data store, and that'll just be framework.service, and a shortcut to access the client data store service. So now we can do IOC.client data store. So in our code, it's nice and simple. Anywhere at all in our whole application now we can do that, and we can do get login credentials. And we could await that and do what we want with it. So we've now got a clean way to access the data store. And as mentioned, we need to ensure the data store. So this is where we want to do IOC.clientDataStore.ensure data store async. And we need to await that. So in here, application setup isn't a task right now. So we'll change it to one, async task, and rename it to async. And now we can await there. So that will call the database creation. And then we just have to bubble back up to here, and we need this to now be asynchronous. So there's a nice trick in C# 7.2, I believe it is, that we can now do an asynchronous override, even though the original method isn't asynchronous. And all this does is then wraps this up in a task for us, so it still returns, but this is off the thread of this override return. So stuff you basically don't really need to know about. Just chuck an async in here, so we can now do await here. And that's all you really need to know. So we have, and I will do a video on this async stuff, by the way. So I know you don't know it yet. You will want to know it, but in terms of for this video, you don't need to be bothered about that little that setup part there. So now we await this, then it starts, then we set the window. This hits here. We know that works now, and now we finally call ensure data store. So if we were to hit the ensure, that one's done now, close that, that's working, close that, go to ensure data store here. So now we have to run the application and open the folder. I just missed it. You can see in the bin folder debug, which is the one we're running, debug, there's no Facetto word.db file. As soon as we run this ensure created, this is where actually we will probably hit the issue I'm talking about, where it doesn't find, there you go. So the type initializer for SQL connection through an exception. The inner one is DLL not found, unable to load SQLite. I'm presuming this is a bug. I haven't really done much research. I'm like, okay, it's trying to find the SQLite DLLs. So if I go to here, you can flick through, and you've got Microsoft.data.SQLite, and you've got them here. And we have in total 65 items in this folder. If we go to the relational bin debug, nothing really different. So it appears to me, and like I say, I haven't done much research, that we have everything we need in here. We've got the SQLite DLLs, but it's complaining. So in this project, the Facetto word, and this is something you shouldn't have to do, by the way, is now we're going to have to add a reference to the SQLite package. Even though this application isn't directly making use of it, the referenced one here is. So this is not something we should have to do in my eyes. Well, I know we shouldn't. So if we install this into the top level project for now, being aware that this should not have to be done, and we should hopefully remove that in the future, if we run it now, For one, we'll just recheck this folder, see if any new items appear, so we kind of know if it was physically added. So no, there's no additional physical content there. But now when we ensure create, it works, and we now get the database file. So this is now an SQLite database file. But that step there, I don't think is needed. So what I've got a feeling is that part of this package in here helps resolve this locating of DLLs, and by adding that, it's needed. So I'll report this after the video as a potential bug to the GitHub repo for this, and we'll see if it gets resolved, and if it does, I'll update you in the future. But for now, that's the workaround for that I just don't feel is needed. So now we have a database. It's simple as that. We've run the application. When it starts up, we ensure the database exists. And now we have a database. So now let's get to the point of actually making use of that and deciding whether we're logged in or not. So the app startup here, we can remove that breakpoint now. The app startup, we go to a page. Well, basically, the reason we go to a page is because we go here to the main window, and the main window is bound to the application view model. And the application view model by default right now is login. So that's why we're going there. So if we change that to chat, say, and run the application, we'd go to the chat page. So that's kind of the reason it's working right now. We simply set a page by default. And that's where we end up. So if it all went wrong and for some reason something failed, I think we should still go to the login page. But for now, let me just change it to the chat so you can see it actually changing. So what we want to do here is decide, set up the application view model based on if we are logged in. So all we'll do here is do ioc.application, which is the shortcut to the application view model, and use the helper go to page. And this is now simply expecting a page. So we'll then do ioc.client datastore has credentials, and is that an asynchronous, which is also named wrong. Async client datastore has credentials async. This will also, it's async locally, so we can await that. Await has credentials. If it does, then we'll go to chat. Otherwise, we'll go to login if we're not logged in. That will probably just want to be wrapped because it's complaining, I believe, because it's not wrapped, because the await. Well, for one, it's the async, isn't it? Now, is it fine with doing that? Yeah, so here now we simply do go to page, and depending on if we're logged in or not, we decide which page to go to. So go to page, have credentials, chat, otherwise go to login, basically. So it's a, you can see the logic. So say if we are logged in, and we've actually done this back to front. Oh no, we haven't done it right. Go to chat page. Otherwise, go to login page. And you can see by default the application view model is set to chat. So this logic should say has credentials. We'll hit up our data store for has credentials, which will hit up our basically get login credentials. So we should end up on the login page here. So it starts up, ensures the database, it's quite happy. We've asked it if it's got credentials. This goes, okay, do we have login credentials? Return the first or the default. It will then return that it's null. And so we should have, it didn't really show as much there doing that, but we should have now in here, current page should be login. And we can't do that because it's inside the dependency injection. So we run, you can see it's gone to the login page. So we now have the presumption that this works. We'll know as soon as we log in and then save the data and get the data out. But you can abstract this and play with it to prove that, but that should work. So now we've got the details. We want to save them in this part here. So this is where we now want to commit them to the actual database. So we have the data, get the user's data, store this in the client data store. So this now will say we've logged in successfully, ioc.clientdatastore.save login credentials. Make a new credentials model, and then here simply pass in the user data.email, first name is user data dot first name, last name, and you get the point. It'll literally just pass in all the data. And then username, and finally the important piece, the token that we want to make use of. Pass in the token. So that should now, we've got to await that because it's an asynchronous task. That should save the data and commit it to the physical database. We could pull it back out here to see. We won't leave this piece of code in. We'll just do this to show you. So var get login details equals ioc.client.get login credentials, and that needs to be awaited because it's a task. So if we run this now and we log in successfully, I've got the server running in the background, so I'll just run up the Versetto word server. You can see as well this login is fine. We get to the home page. This database is 12 kilobytes exactly, which is the table structure, I believe. Now if we go to here and we log in, so Angel6 password, that should successfully hit there. We've got the data, we've got the token, so we'll run this save login credentials. This will go to here, it will remove any, which there aren't any. It should add them to the login credentials. So now we have a local list of one, and then we save to the database. So at that point now, that line's run, our database should have changed size, which it hasn't. Oh, maybe we just haven't ran enough through the threads for it to kick in. Or maybe this database isn't going to change size that easy. Maybe there's a small size, not sure, but I'm pretty sure that data's in there now. So if we then try to pull it back out of the database, you can see we have the data coming back out. So if we now, we'll also have to update this. I think that's actually fine, but run that now and we're in. So if we were to restart the app now, this time, this check here has credentials should return true, and we should end up at the chat page this time when we're starting because it's saved in the database. And there we go. So we're now in the database. And I'm sure you can, well, we can get a SQLite database reader to read this file if you want to see the info in there. But I can guarantee that data is, in that database because we're pulling it out of it. So now we've got the data in there. The issue we'll have is now we've started up and it opens, go to settings, and this is the dummy data that we added. This is the fake data, if you will, which we should also remove. Where do we add that? So we don't get confused that we think it's in some way real. Settings, view model, constructor, remove this. So what we need to do is here in the settings view model itself, we want to really load the information. So it all depends on if we want to, load it when we start up, or whether we let someone else load the data for us. So I'm just going to make a command and call it load command. Loads the settings data from the Client Datastore. In here, this will be load command, new relay, and it'll be load. And then we just make that function now. Log out, clear data, blah, 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 public void load. Loads the, sets the settings view model properties based on the login, or based on the data in the Client Datastore. So now if we want to load to set this up properly, in here we can just do for stored credentials, and you can see how nice this is. From anywhere on the whole application, we can just do ioc.client.datastore and access the data store. So we'll get login credentials async. This will be, now there's a point, we have relay commands that aren't asynchronous. That's something I haven't really thought much about, actually. Something we probably should think about. Not that it matters too much, because we're not doing anything with it there. We can just do task.run for now if we wanted, and run a task to do the work. So that's okay for the minute, because we need the asynchronous to, wait for that. So we will get the stored credentials. And that will pull in any credentials. Then regardless, we'll set the... I shouldn't have deleted that thing, you know. The original with all the info in. In fact, if I cut what I've done... Oh no, I've done too much work. Screw it. I'll just put it back in. Label equals name. Original text equals... in fact, let me just copy and paste from... oh, I haven't got it anyway. Never mind. So this will be... Shouldn't be too hard. Stored credentials, question mark in case we don't have any. So that'll be unknowable. And first name, and then space. Get rid of that, close down. That will be stored credentials, question mark dot last name. So we set up the first name and last name there. We have name, username. All we really had to do here was edit this little bit with the original up here, or wherever it was. Oh, hang on. Is it not getting lost here now? It's this bit we want to do, isn't it? This kind of setup here. So we can copy that. I knew we'd go somewhere. Done the first one though. So copy that out, cut that, remove that bit. So this is where we now do store credentials .username.email. So there we go. That's the setup for loading the data. So we load it in there now. And now in the load here, we just want to then delete this part. We don't need that get because that was just for check. And then we go to page. But right before that, now we've logged in and now there is some new data. We want to load the settings. So now we'll do ioc.settings.load, which will then simply go in and pull from the database the saved credentials and set them up. So this time if we run, we're already logged in, so it's simply, oh, there's a point as well, we're already logged in. So this runs if we log in and we set up the settings page. So right now we still have none because we're already logged in. This settings.load happens once we log in. So load new settings. So we also need to do this load on the app startup. So we can load everything there and then ensure the client database and load the new settings. So at least it loads the initial settings, and that's before we then set up the page. So now we get in, we load the settings, we have a complaint now. Second operation started on this context for the previous completed. So we have we not thread saved the database requests? No, we haven't. Oh, because it's a task, and yeah. So we're going to have to thread save the database call. It's interesting now we've got two login credentials loading. Actually, where are they coming from? So has credentials, return that. Await the client store has credentials. What else has run that? Because we've awaited that one to finish, so it's not that one. We've loaded that. I'm not even sure where the second one's coming from, to be honest. Where have we got back to? Call stack. Second operation started on this context. Oh. No. Let me just... The only place for accessing the DB context is there. Let's just breakpoint when it's created. Run there. So let's just run that again and let's see. I'm not quite sure where the second one's coming in yet. We get one. Ensure created. So we've hit this twice, so I should have watched the breakpoint on why it's hit twice. So context awaited. So first one is being called from the task.run in the settings view model to load. So we really want this to be asynchronous correctly. So my little thing that we should be okay was an invalid statement. What we should do instead is change this to a task, an awaitable task, and we await there, and this is load async. And we will then, in the method here, relay command as load async, and it's expecting an action, so we'll have an asynchronous one for now, and that will run the task for us. So what this means is if we ever use load from the UI and we clicked a button or did some action, then this load would happen asynchronously. That solves this initial problem. The other underlying problem that we'll sort in the next video, I guess, is that we obviously need to make sure that all these calls are thread safe to the DB context, that we don't have the exact same call, or the query, if you will, running at the same time on the same object. So we'll lock all this up and make sure that all these calls are using the async awaiter, which I believe we already have. If not, I'll make it. I think I put it in the DNA framework. Yeah, the async awaiter. So we'll lock this whole database context stuff with the async awaiter. But for now, this should solve this problem immediately in this specific bit of code. Does not contain definition for load. Yes, we know, because now it needs to load asynchronously, and it needs to await that load. Right, try again. Still complaining. Same again here. Await. Async load async. Async load async. That wasn't right. It was await load async. Right, so now we should open. It's logged in. It's loaded the properties. So that's worked. If we were to then delete the database, so goodbye database, start back up, it should create another database. So we can see that it's created a new database, and we're back to the login page. So now this will use the logic not from the app loading, but from the login here to then load. So if we then do angel6 password and login, gets to there, loads the settings, and now the settings page has got the properties as well. So I think that is everything I want to cover here, or everything we need to. So what we have now is a database that we can now store data to through use of this Client Datastore. So when we want to add to this now and expand on it, what we'll have to do is, for one, edit the interface in core so that our Faceta Word application is naturally capable of now, being aware of it and doing stuff with it, as well as the view models in core can make use of it. And then obviously change the implementation itself in here to do the new things to the database. You want to add stuff to the database, just add a new DB set up the binding to whatever you want to do. And then in the data store, you have access to those. So this is the starting point now where the application is self-aware. It can now log in and ensure the database. It can save the token. So at this point, once we're logged in and we decide to now want to say the next step is probably either one, it'll be to actually create this register so we can sign up and get that working. Or we then start thinking about getting the chat list and things like that. But to be honest, for the chat part, we first need to establish a lot more of the database. We need to create the structure for having friends, if you will, having multiple accounts and having a link between them and how we link that. And there's a lot of thinking to do there. So I'll probably link up the logout to successfully log out and remove the token from the server. We also need to do the server code that actually, we mentioned in the previous video, correctly be able to log out a token-based authentication. And then do the register page so that we can register an account properly. And then after that, we'll start doing the actual chat and the friends and how we go about that. So as always, if I've been useful and you'd like to support me, I do have a Patreon page. I'll put the link in the description. Any comments or questions or help you need, just again leave the comments and I'll get back to you. But hopefully this was a useful video, and now you can finally log into Faceta.word.